Let's now look at another example. This example is very similar to the one we finished in the previous video. And look at this one over here. Now we introduce a notation S2n that stands for the sum of squares of natural numbers up to n. So let's show the formula of this sum is equal to n plus 1 to n plus 1 over 6 using induction. Induction involves 3 steps. So we're going to start from step 1. Usually we specify these steps so that we can clearly see we are proving it using induction. So what we have first step, we want to show the formula holds when n is equal to 1. So when n is equal to 1, on the left hand side we have this sum. So S2 1 over here is going to be 1 squared, and this is 1. Then we look at the right hand side, n is equal to 1, so we have 1 times 1 plus 1, and 2 times 1, that's 2, and then plus 1, and divided by 6. And we see over here, of course, this is 2 times 3 divided by 6, and it's equal to 1. So when n is equal to 1, the formula holds. Okay. So this over here is multiplication over here. Now, the second step doesn't involve any verification or any proof. It's assumed. So you're going to assume the formula holds. What it means is that now we're going to assume that S2 n minus 1, that means the sum from 1 to n, the squares of n minus 1, is equal to, this is what we have, 1 squared plus 2 squared, and keep going until n minus 1 squared. We're going to assume this one is n minus 1, and n minus 1 plus 1 is n, and then 2n minus 1 and plus 1 over 6. And we want to show now, the last step over here, we want to show it is true for n. That means now we consider S2n over here. S2n, we see that's simply 1 squared plus 2 squared and plus 3 squared, and keep going until n minus 1 squared, and of course now we have additional 1 n squared. If we look at this one over here, we have this is exactly S2 of n minus 1 and plus n squared. Now use this formula over here, then we have n minus 1 times n, and we have 2n over here, and minus 1 because you have negative 2 plus 1, right? And then we have 6 over here, and then plus n squared. Again, we are going to use the common denominator 6 over here. So what we have over here is 6, and n minus 1 times n, and times 2n minus 1, and then we have 6n squared. Pull out a common factor n, then we have n over here, and what we have is n minus 1 and times 2n minus 1, and then we have plus 6n. That's what we have over 6. And we see most of the calculation is in the last step 3. Other 2 steps are usually very simple, and this is going to be 2n squared, right? And then we have minus 3n, and then we have plus 1, and then plus 6n, right? And then divided by 6. We combine these 2 terms, we have then n over here, and we have 2n squared and plus 3n and plus 1. If we factor out this quadratic form, then we have exactly what we want, n and n plus 1 and 2n plus 1 over 6. That's it.